Move on to question number 4. Just going to clear the page. Alright, so question number 4. So now we're taking the integral of ln x. So we did some derivatives, now we're going to do an integral in this question. This is question number 4. So let's go through what the junior tutor did here. So the function given in the question is ln x. So this is an important integral to know. Sometimes you would memorize this integral because it's a commonly asked question, but we'll go through the steps of how to get to the answer. Excuse me. Okay, so and there is no direct method of integrating ln x. The integration of the function we need is to use integration by parts. So this is what we're going to be using to do the integral. So here we can see ln x. This is the integration by parts, and to go through the process step by step. So I'll write down the formula for integration by parts. So it will be as follows. It will be the integral of u dv equals u times v. Let me just write that again. So u times v minus the integral of v du. So u and v are just placeholder variables, and you'll see how this is useful in a second. So if we thought about the integral of ln x, we want to solve for this, what we'd do is we would set u equal to ln x, and we would say dv, so there should be a dx over here, will be equal to dx. So we'd set up the variables of the integration by parts formula as follows. And then we would say that du, so the derivative of u, which we set to ln x, is just 1 over x, because we know the derivative of ln x is 1 over x, dx. And then we want to also evaluate for v here. So we'd say if we integrated dv equal to dx, we would get v equal to x. And now we've defined the 4 variables, or not variables per se, but the 4 things that we need to plug into the integration by parts formula. So looking at this, kind of we've said this is u, this is v, sorry, this is dv. We kind of set it up the same way. So all we really have to do is plug in these values. So we'll say, we'll put this down here, we'll say this is equal to u times v, so it will be ln x times x. So ln x times x minus the integral of v du. V over here is x, du is 1 over x dx. So we have x 1 over x dx. And then going on, we can see that the x's cancel out, and we're left with x ln x minus the integral of dx. And you can see now how this kind of simplified down to a simple integral that we can easily evaluate for. So the integral of essentially 1 dx is just x. So we get x ln x minus x, and then we have plus c for the constant. So you can kind of see how this is useful. So right away we can't really, it's kind of difficult to evaluate the integral of ln x without kind of splitting it up into integration by parts and then ending up with this solution below. And we can see that the junior tutor obtained the same answer as shown here. So we'll mark this solution as correct. So correct answer. Great job. And we'll go to the next question.